Now I'm going to show you guys how to find absolute extrema on a closed interval. So finding absolute extrema on a closed interval. Okay, so to find the extrema of a continuous function on a closed interval, let's say the closed interval a to b, you want to use the following steps. So 1, you want to find your critical numbers. Of f in a, b. And notice that this is the open interval a to b. Then you want to evaluate f at each critical number in the open interval a to b. Then you're going to evaluate f at the endpoints of a to b. And finally, the least one of your values is the minimum, and the greatest is the maximum. So now I'm going to take you guys through an example so you kind of understand it. Just keep these steps in mind. I will go through it as we approach the next example question. Okay, so the example problem we're going to do is, let's say a problem gives you locate the absolute extrema on a closed interval 0 to 4 given the function g of x equals x squared minus 2x. So your first step is to find critical numbers. However, in order to find critical numbers, you need to find the values of x when you set your derivative equal to 0. So when your derivative is equal to 0, you want to find all your x values that set it equal to 0. So I'm going to show you how to do this, how to find your critical numbers. So your first step is to find the derivative of g of x. So the derivative here, using the general power rule, is going to be 2x minus 2. Just brought the 2 out in front, subtracted a 1, brought the 1 out in front, multiplied by 2, and subtracted 1 from 1, so you get x to 0. And this is 2x minus 2. Now you are going to set your derivative of g of x equal to 0. So you have 2x minus 2 equals 0. And when you solve for x, you get x equals 1. Now this is your critical value. So in this example, you only have one critical value. You could have 1, you could have 2, you even could have 3. However, in the example that I have given you, we only got one critical value. Then you will evaluate f, as the second step said, at all the critical values. So our function was x squared minus 2, so we're going to evaluate f, or g of x, the function, at x equals 1. So g of 1 equals 1 squared minus 2 of 1. And all I did was plug the 1 into the original function, and you get g of 1 equals 1 minus 2. So g of 1 equals negative 1. So this is 1. However, you are not done here. You now have to go on and evaluate both of the endpoints of your interval. And out of these 3 values, you're going to look for your least and greatest numbers. The least number will give you the least number will give you the minimum points, and the greatest number will give you the maximum points. So keep that in mind. So far we have negative 1 as when we plugged in our critical value. Now we're going to plug in 0. So g of 0 equals 0 squared is 0, minus 2 times 0 is 0, so it equals 0. So we have when x equals 0, when we plug that into our function, our outcome is 0. Now we are going to plug in the 4. So when we have g of 4, it's going to be 4 squared minus 2 times 4, which is going to give us 8. So g of 1 gave us negative 1, g of 0 gave us 0, and g of 4 gave us 8. This being the least is the minimum, and this being the greatest is the maximum. So, as simple as it sounds, your minimum now is 1, negative 1, and your maximum is 4, 8. It's very simple to understand. You just look at these values, see which one's the greatest and the least, and there's your points, and those are your absolute extrema in the closed interval. However, it is important to keep in mind that there is a difference between absolute and relative extrema. Relative extrema is on an open interval, so the endpoints are not possible maximums or minimums. An open interval, instead of it being from A to B, it would be from A to B. So you cannot test these points when looking for a maximum or minimum, as when solving for relative maximums and minimums, they will not be possibilities. However, you can have a relative maximum or minimum in the interior of the interval. So it's just important to keep that in mind, but this was how you solve for absolute extrema on a closed interval.